Welcome, grade 11 and 12, physical sciences. We are going to look at types of reactions. But the focus of today's lesson is to identify the acid and the base, knowing how to get the conjugate pairs, identifying the conjugate acid, conjugate base, and also knowing the ampholyte. And later, we will treat a few questions which will be based on what I'm going to present. So, here we have definitions of acid and base. According to Bronsted-Lowry, acid is defined as a substance that gives away proton. Acid is defined as the substance that gives away proton, which is H+, and is therefore called a proton donor. A base is a substance that takes up proton and is therefore called a proton acceptor. Acid gives away the proton, base accepts the proton. So, according to Irenaeus, acid is a substance that ionizes in water to produce hydrogen ions, which is H+. So when this hydrogen ion is produced, it will be accepted by the base. Base is a substance that ionizes in water to produce hydroxide ions. When this base ionizes in water, OH minus will be produced. I just have to eliminate one, ionizes there. So, for example, we are going to make use of these two equations here. Let me use my pointer. Example 1 and example 2. So, you can see on the side of reactants is HCl and H2O. And then on the other side, we have our products. So, how will I know which one is an acid and which one is the base? So, the clue or the answer is in the definitions. The definitions are the one that will enable me to know which one is a base and which one is an acid. A substance that gives away a proton is an acid. So you come and check the reactants and the products. Look here, let's first look at hydrochloric acid. On the side of the product, you can see that H is no longer there. It means that something had happened here. Now, let's check at H2O and also check on the side of the products. You can see that on the side of the product, something happened here. There's an addition of something here. So what happened here takes us back to the definition of an acid and the base. An acid gives away proton. If we come and check here, between these two reactants, HCl is the one that gave away the proton. And then as a result, we find that it becomes a chlorine ion. The H plus that was given away by hydrochloric acid, it was accepted by H2O. And then when H2O accepts H plus, it becomes H3O plus. So the one that donated the proton is an acid. And then the one that has accepted the proton is the base. So we have something called conjugate pair. When an acid gives away a proton, it becomes chlorine ion. So HCl and chlorine ion, they are referred to as a conjugate pair. When a base accepts a proton from an acid, it becomes H3O plus, which is hydronium ion. So this is also another conjugate pair. Let's look at the second example. Ammonia reacting with water, and here are our products. So our task is the same, to identify the acid and the base and also the conjugate pair. So by looking at the products, you can tell what had happened to our reactants. For us to get OH minus, something had happened to H2O. H was, or H plus was given away. H plus was lost here. And we were left with OH minus. This minus is telling us that water has given away a proton. That's why we have to put minus to show that it has lost. The H plus that was given away by water, it was accepted by NH3, which is ammonia. And then when NH3 accepts H plus, it will become NH4 plus. To show that it has accepted the proton, we put positive there. So here, the one that has given away proton is H2O. This tells us that it is an acid. And the one that has accepted is NH3. This tells us that this is the base. Acid, base. So, conjugate pairs. H had given away the proton and becomes OH minus. This is the conjugate pair. NH3 has accepted a proton and becomes NH4 plus. This is also a pair. There's another thing that I want to talk about here. Conjugate acid and conjugate base. When an acid, which is HCl, gives away a proton, it becomes conjugate base. When an acid gives away a proton, it becomes a conjugate base. When a base accepts a proton, it becomes conjugate acid. When a base accepts a proton, it becomes conjugate acid. Let's talk about ampholyte. What is this? It's a substance that can act as an acid or a base. It can donate or accept a proton. Let's go back to previous examples. Or let me first name the two substances that can act as a base or an acid is water and HSO4 minus. Let's come back to this example that I was busy with. Now the focus is ampholyte. Let's look at example number 1. Hydrochloric acid and water. In this example, water has accepted a proton from HCl. It is acting as a base because it has accepted. But in example 2, water had given away a proton. It has donated a proton. In example 2, it is acting as an acid. Another example of an ampholyte is at number 2 here. HSO4 minus as a base. Let's look or let's check what happened here. This is a synthesis reaction. Synthesis reaction. Something had been formed here, which is H2SO4. And then what happened when H2SO4 was formed? HSO4 minus accepted a proton, H plus, and it becomes H2SO4. If you check here, we have negative. When a substance accepts, we add +1. Look at what I've done here. HSO4 minus accepted a proton. It becomes H2SO4. But what happened here? It has its 1 or -1. Because it has accepted, I must write +1. And then getting the sum of here, we get 0. That's why we have nothing here. Because some might be wondering what had happened to this negative. It did not just disappear. Because this has accepted a positive proton, we'll come and put -1 +1. And this will give us 0 here. Here, HSO4 minus was acting as a base. In the second one, it is acting as an acid. The type of reaction here is decomposition. When HSO4 minus decomposes, you can see that it will give away a proton here, H plus. And it will become SO4 true minus. I've shown it here what happened when it comes to this negative here, because you can see it was minus 1, now here is minus 2 or 2 minus. When this gives away, we will add negative 1 here to show that it has lost a proton. Because we already have negative 1 here, this will become negative 1, negative 1, which will become 2 minus. I want us to solve some, or to answer some questions. But answering these questions will require us to first look at what I've put on the screen there under conjugate acid-base pairs. When acid gives away a proton, it becomes conjugate base. I have mentioned this already. When a base gives away or accepts a proton, it becomes a conjugate acid. Let us answer these few questions based on what I was talking about. Write the conjugate base of HBO3 2 minus. Write the conjugate base. Let's come back to this information here. We are required to write the conjugate base of what? Of HBO3 2 minus. This tells us the following. HBO3 2 minus is an acid. So if it is an acid, for it to become a conjugate base, it must give away the proton. HBO3 2 minus must give away the proton, which is H plus. When HBO3 2 minus gives away the proton, it will become, let me write it here. It will become B, because it has given away H plus. B, O, yeah, 3, 2 minus, because it has given away a proton, what do? We'll add minus 1 here. If you find the sum of this, your final answer will be B, O, 3, 3 minus. Let us look at B. It says, what is the conjugate acid of HC2O4 minus? I'll take you back to this. In this one, we are required to find the conjugate acid of this conjugate acid. What does this tell us? It tells us that HC2O4 minus is a base. And what happens to a base? A base accepts. If this base accepts a proton, what will it become? That's what we must answer. What is the conjugate acid of HC2 C2O4 minus. We want the conjugate acid, which means that we're given the base, and the base must accept a proton. So the following will happen. This base is going to accept the proton. H, because it has accepted a proton, we have one H here, now there'll be two. H2. C, this is my C. C2O4. We already have negative here. Because it has accepted, we'll put plus 1, minus 1 plus 1. So the final answer will be H2C2O4. This is our final answer for this question, H2C2O4. Let us look at C. For each of the following, write down the formula of conjugate acid. For each of the following, write down the formula of the conjugate acid. How do we get a conjugate acid? How do we get conjugate acid? It is from the base that has accepted a proton. If a base accepts a proton, it becomes a conjugate acid. It means that here, all of these, we are given bases. All of these are going to accept a proton. So let's answer this one. All of these are going to accept proton. All of these are going to accept proton. Answer for the first one. NH3 will accept a proton, and it will become NH4. Because it has accepted a proton, we'll put plus here, NH4 plus. The second one, I said all of them are going to accept proton because a conjugate acid is formed after a base has accepted a proton. All these are bases, so they will accept a proton to become a conjugate acid. In this one, NH3, because it has accepted, we will add the plus 1 here. We already have negative 1. When we add plus 1, this 2 will give us 0. That's why we have NH3. Let us look at the third one. When this accepts a proton, the following will happen. C10, H15, N2. Because it has accepted a proton, we'll put plus here. Let's move to the last question, which says, for each of the following, write down the formula of the conjugate base. Write down the formula of conjugate base. I'll take you back to this. We are required to write the formula of a conjugate base, which means that we are given an acid. We are required to write the formula of conjugate base, which means that what we are given here, these are acids. these are acids. And we are required to write the formula of the conjugate base. What will happen to these acids to get a conjugate base? They must give away protons. Protons must be given away by these acids so that they will become conjugate bases. So let us answer the first one here, which is Roman figure 1. HCl is an acid. When HCl gives away proton, it becomes Cl minus. This is the final answer. Then the second one, when H2SO3 gives away a proton, it becomes H. Remember, we have H2, now we'll be left with one H here. HCO3. Because it had given away a proton, we'll put negative here. And then the third one, this H will be given away. And then we'll be left with P, is P, O, 4, 2 minus. Because it has given away a proton, we have another minus here. The final answer here, it will be PO4 3 minus.